welcome back. Another day. We're gonna crack at the code interview. Hello. Hello. Welcome back. Welcome back to another episode. Another episode of cracking the coding interview with Rust. My name is Brenden. This is the book. We're doing it. We're doing it in Rust. Hanging out here. Doja's here. She's sleeping right now. Just hanging out right there. There she is. Oh, she just woke up. Camera's not gonna focus. I should turn some lights on. It's kind of a cloudy day. It's supposed to start snowing. Crazy winter storm. Winter storm. Let me get some lights. Get some light in here. There we go. I think that's better. How's the sound? Is the sound working? I should do a sound check. Make sure that sound's actually working. Sound check. It's kind of a cloud. There we go. Okay, I hear my voice. It's terrible thing to hear. Hear yourself. Anyway, welcome back. Another episode. We're going to crack the coding interview with Rust. Yesterday we got to what did we get? We're on chapter 2. We got through to problem 6. There's 2 more problems left in chapter 2. Problem 7, problem 8, and then we're on to chapter 3. How exciting. So maybe I'll finish those today. Maybe we'll even start chapter 3. Let's do a little preview. Let's see what chapter 3 is about. Chapter 3, stacks and queues. Fascinating. Cool. Okay. Chapter 2, by the way, is about linked lists. That's the topic. This is these are the problems we're doing. It's not that readable, but sort of. So let's do a quick recap as well, just where we were. Switch screens here. Here is the project if you want to follow along, if you're interested in the code, want to take a look at it. It's up on GitHub under on my GitHub profile, which is my name, no vowels, / cracking the coding interview Rust. There's an implicit with in there that isn't in there. But anyway, there it is. Check it out if you want to. You can fork it, make some changes. It looks like there are 0 forks, so nobody has forked this yet up to now. But anyway, let's do it. Just to look at where we've come. So what we are, let's see, chapter 1 had 9 problems. Chapter 2, we're 6 problems into chapter 2. We're gonna start on 7 problems. So we've completed 15 problems of what? There's 189. Got a long way to go. It's gonna take a while. It seems to be about an average of like 1 to 2 hours per problem. However, I think that statistic is really skewed because some problems take a lot longer than others. For example, just implementing a linked list originally at the start of this chapter was really hard. I didn't know how to do it in Rust since I'm just kind of learning this as I go. And it was a little trickier than I thought it was going to be to figure out all of the language details. But anyway, we got it. Got it going. We're good now. So let's keep going. Let's do it. We are on problem number 7. Let's just get ready here for number 7. Let me just copy number 6, paste. That automatically renames itself to number 7. So we're gonna go from there. And let's look at the book. Switch to the book. and let's see what problem 7 is. I took a little sneak peek already, but I already forget what it is. Okay, problem 7, it's called intersection. Let's see if we can get the camera to focus. Oh, not bad, not bad. Okay, intersection. Given two singly linked lists, determine if the two lists intersect. Return the intersecting node. Note that the intersection is defined based on reference, not value. That is, if the kth node of the first linked list is the exact same node by reference as the jth node of the second linked list, then they are intersecting. Interesting. So I haven't thought about doing something like this in Rust because up till now I haven't really tried to share ownership, I think, across lists. In other words, the assumption I've had is that if an item is in a list, it is owned by that list. That's currently the way it is, right? Like the data part of my list implementation implies complete ownership of that item. So this would be relatively easy to do in like C or C++, but it's a little trickier doing this in Rust. Wonder if I can do it in a way that doesn't require changing my existing linked list implementation too much. Let me just read the problem again, make sure I understand. Intersection. Given two singly linked lists, determine if the two lists intersect. Return the intersecting node. Given that the intersection is defined based on reference, not value. That is, if the kth node of the first linked list is the exact same node by reference as the jth node of the second linked list, then they are intersecting. So I think in order to do this properly, I have to change my linked list structure slightly. So let's switch the code. Let's look at the code. So right now my node is defined as, I have basically data of type T, but I need to have a reference to the actual data. So I think this is pretty straightforward. I'm actually just going to copy my node ref here and call this data ref, and essentially do the same thing. Rather than this being a node of T, this is actually just T. Right? And then my data, instead of being data of type T, this is going to be data ref of type T. Yeah? So now, also it says this should be a singly linked list. So I have to change, I'm going to drop the tail and the previous node, I gotta change this back to being a singly linked list, which it was before. Get rid of all these. Oh, you know what? Hold on. I'm gonna just abort because I actually have to change the code to make it singly again. So let me just delete problem 7. I'm gonna just trash that. I'm gonna copy problem 6 because problem 6 is not doubly linked. Yeah, that's just a singly linked list. So let me go off that. Problem 5 will be the basis for my problem 7. All right, there we go. So, whoops. Let's add a data ref type, and that's basically the same as this, except it just points to T. Data ref T, like that. So everything else is pretty much almost pretty much the same. Let me get rid of these functions from problem 5. Get rid of all this crap. Sum forward, delete, test intersection, call it. Just make this empty. Get rid of this test. Delete this, whatever, blah, blah, blah. Okay, I need to change my insert or append method because new value is going to need to be a node ref. So rather than type T, it's got to be, sorry, a data ref. It's going to be a data ref of type T. Yeah, okay. Let's see if that compiles. Probably not. I'm probably missing some stuff. Mismatched types, expected type parameter. All right, what's going on here? Data, new value. New value, data ref. I think this needs to be copied like that. Right? As ref, clone. Okay. There should be new RC. Actually, no, because I want to keep the reference itself, right? I want to keep the, so the ref cell, I believe is, yeah, okay, so I want to clone the ref cell, right? Yes. As ref. No, hold on. Can't clone the ref cell. It's the, so data ref, yeah, data ref's RC. Okay. So this, I think where I'm going wrong here. No, data is not an option. Expected type parameter found struct. What am I missing? Oh, I forgot to change this. This should be data ref of type T. There we go. There we go. I think that is gonna be okay. All right. RC new, ref cell new. Something like that, right? Boom. All right. Seems to work. Let's okay. What's going on with my VS Code? Let me reboot the computer. Thought we had moved past the point where we didn't have to restart stuff, but oh no. Argument character must be non-negative. Dismiss? What's happening? What's happening to my editor? Paste. There we go. Okay. This is a little hard. All right, so let's make 2 lists, and I'm going to compose those lists from the same set of values. So let's make some, we'll make a vector of data. So we'll call this data vec equals, and then make a vector, and we're just going to put some values into it like this. 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, whoops, 4, 5, 5, 6. Yeah? Does that compile? Are we good? Are we happy, compiler? Are we a happy compiler today? Yeah, look at that. Okay, cool. So we got that. Now let's make first and second. First list will contain, let's say, the first 3. Yeah, let's make it 5 items. So we'll put the first 3 in first, and then the last 3 in second. Yeah? Okay. Okay, for value in divvec dot, how do I do a range of a vector? Rust vector range iter. I want to iterate over a range of values. What is the right way to do that? I don't know. Splice creates a splicing iterator that splices a specified range. Okay, yeah. No, I don't think that's what I want. As slice, is that what I want? I just want a range. Does iter, how do I iterate over a range? Rust vector iterate over range. For blah blah blah. That's what I want. I want like the I want an expression similar to what Python has. I think the way to do it is, I'm looking for like a pretty way to do it, but I think the way to do it is to just go do up to divvec. Or actually, yeah, 0 up to, I'll just say 0 up to 3, like that. That'll do it. That'll do what I want. It's maybe not the most beautiful way to do it, but it'll do what I want. Okay. So from 0 to 3, whoops, for value, this should be doing this. And then here it'll be like from 2 up to 5. Right? Yeah, okay. That should create my overlapping, whoops, this should be second 3. That should create my 2 overlapping lists. So there's first overlapped one, the second overlapped one. So I can just say assert equals lists intersect. Sorry, I should say intersect. Intersecting overlapped intersect. Lists intersect. Intersecting first, intersecting second. True. Okay. And then let me create two non-intersecting lists, which will basically be the same as this, but I'll put non in front like that, non like that, change this number to 3, and now those should be non-intersecting. And copy this. Assert equal list intersect, false, non-intersecting, non-intersecting. All right, so now I just need to implement this lists intersect guy. Okay, function lists intersect. Let me just change this. I'm gonna make this a trait, so I'm gonna do it like this. Make it generic. Okay. Add this trait here, function lists intersect self and other of the same type. Is there a, oh, whatever, self. Okay, and it returns a Boolean. Let's just say false by default. Let's see if that runs. Nope, doesn't go. This needs to be a reference. This needs to be a reference. Cargo test, boom. All right, compiles the test fails. That's good. We're good. We're good here. How's everyone doing out there today? Hope we're all having a good day. I am. Doja's fast asleep. Just having a good sleep. We've been out for 2 walks today. She had lots of time at the park this morning, and then we went out again. By the way, to switch gears slightly, I was talking yesterday about another project I was working on, which I released. I made the repo public earlier today, but it's this tool called LabHub. I put a lot of emojis in the README, which I think is like the new trend. So check it out. It's a GitHub bot written in Rust, and it is for dealing or using GitLab's CI tool with GitHub open source stuff. And if you want more information about that, just read through the README. It explains why it's necessary, or just skip to, if you go to this problem section, there's a link here to a thread on GitLab about why I gotta do this. So check it out if you're interested. Maybe not. Okay. Let's go back here. So, all right. So our code compiles. All I have to do right now, I believe, is implement this lists intersect to see if my two lists intersect. And let's see. So let's think about this algorithm for a minute. To see if two lists intersect, I think so. I guess one question would be, do I know anything about the order of the items in the list? Because if I know that that the two lists, if they intersect, they would be like one would be a subset or a superset of the other. If I know that, then I can assume that the order on the intersecting parts of the lists would always be the same, if that makes sense. So that matters because it means I don't need to check every possible combination, because if you need to check every possible combination, that's like it's like an order n squared problem, right? Because you have to check everything against everything. I don't think it should be that way. That doesn't sound right. I mean, maybe it is, I don't know, but I don't think that's what this is. If you simplify it a little and you just say, look for the first, essentially write an algorithm to just search for the first of any references that match, then that is really easy. All you need to do is, well, actually no, that is still n squared. Never mind, because you have to check every, you have to check each against each other. Yeah, so, I feel like that's not a great solution. Let's think about this for a moment. What else does the problem say? Let me reread this again. Given two singly linked lists, determine if the two lists intersect. Return the intersecting node. Note that the intersection is defined based on reference, not value. That is, if the kth node of the first linked list is the exact same node by reference as the jth node of the second linked list, then they are both intersecting. Okay, I don't think there's, well, let me just start writing the code. So yeah, basically I'm gonna have two loops here. Outer loop, I'm gonna say outer node for each outer node in self.iter. Right, I have an outer node and then I have an inner node. For inner node in other.iter. Alright, so for each outer node in my outer and inner is maybe not the right. I'm gonna call these left and right. Or no, other, let's call this, yeah, left. No, let's call it self node and other node. Yeah, that's better. Okay, other node. So I basically just want to compare and say if RC pointer equals, so I'm just comparing two pointers, this and other. This is going to be self node dot borrow dot data, and other is going to be other node dot borrow dot data. Return true. Otherwise false. That's basically it, right? Expected reference. Yeah. Well, that's it. We're all done. Looks like. Let me just get rid of the warnings. dot. Oh. Oh. Help. Remove this. Cool. Well, that's it. Problem is done. Seemed too easy. Probably did it wrong. Oh, Doja's having dreams. I don't know if you heard that. Her little squeak. She just woke up. She woke herself up. Oh. Squeaking? You having little dream squeaks? All right, check-in problem 7. Just push that up to GitHub. I'm gonna take a little break for a couple minutes and be right back. BRB, LOL. All right, I'm back. Need a little bio break. I'm back. Let me. I'm gonna tweet out to my 3 followers on Twitter that I'm doing Twitch. Hey people, come stop by. Come watch my Twitches. My twitching. Come watch me twitch. All right, did it. All right, we're doing this. Live on the internet. The internet's an amazing place. You can be anything you want, anyone you want. I just got a notification that the build failed. It's unfortunate. I am going to go and investigate, see why it failed. Take a little look here at the Travis build. Go to the bottom. Done. Your build exited with 1. It doesn't look like it failed. And yet it did. Oh, I see. Looks like I have some clippy issues here. Let's check my clippy stuff. Loop variable value for item in. I see. Yeah, that looks better. Clippy's always teaching me better ways to do Rust. See, I was trying to figure out. I really thought that there was going to be a better way to do this. And of course, look, there is. Clippy just is telling me. It's telling me what I was looking for, and I couldn't figure out before. But now, here it is. Take 5, skip 2. Ah, tricky. That's so cool. That is really, really cool. Okay, let's copy these down here. This one would be take 2, skip 3. Yeah. Value. It's supposed to start snowing like real soon. It's supposed to be a winter storm. It looks kind of cloudy out, but I don't see any storm happening. Boom. Okay, let's make sure the tests still pass. Nice. Let's apply those Clippy fixes. Apply Clippy fixes, suggestions, whatever. Be cool if Clippy could just fix it for you. Kind of like Clang can do that. Clang format or Clang tidy. Both of them can fix things for you, which is pretty nice. All right, let's look at that. All right, let's go on to the next problem. Let's go on to it. Go on to doing it. We're doing it. Doing the next problem. We are on the last problem in chapter 2. Believe it or not, it's a Christmas miracle. We did it. Last problem, chapter 2. Focus. All right. Loop detection. Given a circular linked list, implement an algorithm that returns the node at the beginning of the loop. Definition. Circular linked list, a corrupt linked list in which the node's next pointer points to an earlier node, so as to make a loop in the list. Okay, cool. So let's start by copying the test in there. Now, I can see, obviously, that this is a follow-up to the previous problem. Now, the algorithm, this is like a problem that comes up all the time because it's like mildly tricky, but also not really that tricky. There's a very well-known solution algorithm for this problem. It is known as the Tortoise and Hare algorithm. Tortoise tortoise and the hare algorithm. Let me look it up. Tortoise and the hare algorithm, right? Yeah, Floyd's tortoise and hare. Anyway, let's see. Just lost my train of thought. So let's build a list with a cycle, and check it out. Doja's sleeping. She's having such a good time. She's so happy. It's gonna be tricky to construct a list with a cycle. I guess I have to manually do it. Yeah, okay. So let's go 1, 2, 3, 4, 5. That's fine. I'm going to make a cycle where 5 will point back to 2, let's say. So I'll construct this list, and then I will change my list to create a cycle. All right, test cycle. Let's call it, let's just make a cycle. Oops, I deleted too much. I want to keep this code to populate my, okay. Let's call this list. All right, so I have a list, and I'm going to create a cycle. I can do that by getting the tail. So let me get the tail of my list. List.tail, and then I'm going to let me get the second node. So I'm just going to go second node equals list.iter.next. I want to get the second. Yeah, so I'll go let list iter equals list.iter. And we'll go list iter next. Let second node equal that. Yeah, there we go. That's what I wanted. That should be it. Okay. Let me comment that out. Let me just make sure this compiles. Doja's just having crazy dreams. She's, let's listen, let's just listen to Doja's puppy dreams for a moment. Hold on. Oh, never mind. I woke her up. She's awake. Sorry, pup. All right, I failed. I totally failed. I'm gonna try and capture her puppy dream sounds. She has the cutest little puppy dream sounds. All right, forget it. Forget that idea. Back to the codes. Going back to the codes. Oh, I messed this up. Yeah, that's right. I forgot. These guys are stateful. Stateful iterators in Rust. Kind of not the coolest, but it's what it is. Cargo test. This should be mutable. There we go. Okay. That works. This gives me my second node, and then here's what I'm going to do. I'm going to update the tail, and I'm going to say list tail Okay, unwrap that as ref, and then say, this should give me a node ref. Yeah, so borrow, and then next, right? Hold on. List tail unwrap. Am I right? Where's the append method? Oh, I need to borrow mutable. That's right. Tail unwrap, borrow mutable. Next equals some second node cloned. Yeah, like that. Cargo test. Oh, I don't need this sum if I'm using cloned. Cloned returns an option. Derp. Method cloned exists. Wait a minute. Wait a minute. What does next return? Returns an option item. Okay, so this should be, yeah, this should be what I want. This is what I want. Yeah, yeah. All right, what am I missing? The method cloned exists, but the following trait bounds were not satisfied. Oh, it's because my iterator is not, or what I'm returning from that iterator is not mutable, right? My next, yeah, next is not returning a mutable iterator, but I should be able to do that anyway because this is a reference, right? Second node, unwrap, borrow mutable, clone, like that, right? All right. I feel like I'm going in a circle. Okay, weird. No, that works. I'm not sure why it didn't let me. No, she's in the bed. Tortoise in the bed. She's hanging out. Nap time. Thanks for dropping by. If you're new to the stream, tuning in. Hope you have a good time. We're learning about Rust and trying to crack the coding interview. This guy right here. If you are if you're new to the stream and you want to follow along, you can. Just a sec. I'm just checking making sure everything's actually working. If you want to follow along, check out the code. You can go on GitHub, look at it. It's on my GitHub profile under my name, no vowels / cracking the coding interview Rust. And you can follow along if you want, or you can copy the code, you can fork it, you can send me a PR if you want. Although I would welcome PRs, however, I'd prefer you didn't solve any of the problems I haven't done yet. If you want to go back and like redo any of the existing ones, by all means. But I'd like to solve them myself first. So yeah, okay. Let's write a function to test for, or to check for a cycle. So has cycle. This is just going to be a trait on the linked list type. Has cycle, and then it's going to return an option of a node ref type T, right? Okay, delete all this. Return none by default. just make sure this all compiles. So let's assert equal list.hasCycle none. The test is wrong right now, but I just want to make this compile first. Assert equals what? What do you mean it can't be formatted? I need to probably derive debug for this guy. Derive debug. Partial equals needs to be implemented. Compare partial equal. As cycle. Assert equals has cycle none. An implementation might be missing. What have I done wrong here? List has cycle. Has cycle. This is the right method I'm calling, right? None has cycle. Option blah blah blah. I see. Okay. Let's just like unwrap this. So cycle result equals that, and then I'll say assert equal cycle result is none true. There we go. That'll fix it. Cargo test, sweet, test pass. Now let's make this what it should be. That should be true. If I run again, that should fail. Yes, it does, sweet. And then let me change this and say, let's call this cycle list. And let's add another test case, which is going to basically be the same, but let's call it no cycle list. No cycle list. Delete all that. No cycle list. No cycle list. Sorry. No cycle result. That should be false. See if that compiles. It does. Bingo. We're in business. Let's do it. Let's do this. All right. Tortoise and the hare. How does it work? It's pretty simple. You create two iterators. One moves at one speed. The other moves at, another speed. And if the two iterators meet at any point, then you have a cycle. That's it. That is it. Really simple. Now, so thinking about this problem, what the problem asks specifically is loop detection given a circular linked list. It says that it should return the node at the beginning of the loop. So let's come back to that. First thing we need to do to detect the cycle is write this algorithm. So let's get two iterators here. We need two iterators. We're gonna have mutable tortoise equals self.iter. and then mutable Hare equals self.iter. Yeah? Okay. And then all we gotta do is say while I need two more values here. Let's call these tortoise iter and Hare iter. Yeah, okay. And then tortoise mutable again equals tortoise iter dot next. So this gives us first value for that, and then same with the Hare iter dot next gives us first value. Okay, and so here we just say while Hare is sum and tortoise is sum. Do this. If we ever get none, basically reach the end, that means that there's no cycle. Okay, easy peasy. And then here all we have to do is compare these two pointers. So we say if RC pointer equal, and we've got Hare dot unwrap and tortoise dot unwrap. So if these are equal, return, sorry, one moment. Yeah, let's just say return Hare dot cloned for right now, and then this would be none. Okay, something like that. These should be option or references. Okay. Hare unwrap. Hare unwrap as ref, right? No, what am I doing wrong here? Unwrap, borrow. Do I need to borrow? Wait a minute. Method cloned exists, but the following traits are not satisfied. I think this needs to be mutable, right? As no, borrow mute. Clone exists, but the following traits were not satisfied. What? I don't think this needs to be mutable. Right, method clone exists. Perhaps you need to implement it. No. So Hare is option. Gonna unwrap the option. I actually just want to clone, like, I just want to clone the pointer. Oh, you know what? I don't even think this needs to be like that, right? Can I just do this? Hare.cloned? No. Some I see. What is going on? It does not need to be mutable. Yeah, it does. Okay, so the next thing that I'm missing here is so Hare needs to become Hare iter dot next, but Hare's gonna iterate twice, and then the tortoise is only going to iterate once here. And then I'll say, I have to check that this is actually valid. Okay. So yeah, basically the way this algorithm works is that the hare moves 2 places through the like iterations for every 1 time the tortoise moves, right? All right, are we in business? Are we in business? Maybe? No. Use of move value. Why is it moved? Next, as ref. Clone. Is that what I need to do here? Enter next as ref. Clone. Value moved here. As ref. How are we doing now? Are we almost compiling? No. Still not right. Expected reference found enum. Need to unwrap these first. Unwrap. Expected RC found ref cell. Yeah. I'm not sure why this causes a move. Value moved here, value borrowed. Method clone exists with following traits not satisfied. Cloned for RC. I think it should just be clone. Right? No. Doing this wrong. Value used here after move, value moved here. So this unwrap is causing a move. Why? Okay, so this is an option. Yeah. Fine. Hare. Let me look at the last one. How did I compare these two? Oh no, I just realized I've been editing the wrong file. Okay, let me copy this. Okay, let me copy this to the next problem. Copy that to problem 8, right? On problem 8? Yeah. Okay. And then let me check out this. Okay, revert that. Now let's open problem 8. And then let me also look at problem 7. Oh, I see, okay. I get it. I need to borrow explicitly. Not unwrap. Self, other node, iter, node borrow. No, this isn't right. Next, I think this is wrong. So this should just be next. Let me just look at next. Next returns an option. Yeah, so that is. Oh yeah, okay, so I get it, I think. Item is node ref. So these guys, value moved here. I want to borrow. I want to borrow those guys. Why can I not borrow that? No method, borrow. Do I have to unwrap and then borrow? So confused. Expected reference as ref. As ref. Expected RC. Rust option. Why? Unwrap. Type option on. Okay. I want a reference as ref self. I see. I think I might need to do as ref unwrap. As ref unwrap to prevent that move. There we go. Okay, and my test is running forever. That means it's busted. That's a good sign, good signal. Okay, that was way harder than it should have been. Okay, iter, next, Tortoise, Hare. Cool. So, oh, this should be return. Return. There we go. So, test currently fail. It's failing it. So this one is failing. It should be is none true. So no cycle result, no cycle list has cycle. That should be returning. It should be returning none. Because there's no cycle, unless I, for some reason, put a cycle into my list. No cycle list. By the way, this does not need to be, this can just be 1, 2, 4, 5. These don't need to be ref cells. I don't need to have this data ref wrapping anymore. Let me get rid of that. Just to simplify the code a little bit. Slight difference there. Cargo test. Okay. Oh, for type T. There we go. Okay, so why left false, right true? Why is this sum? No cycle list has cycle. This can just be value, doesn't have to be value.clone. What's wrong with my algorithm? Why is it returning a thing? Oh, duh. It's because I need to, my Hare needs to move an extra, basically the Hare iter needs to start ahead of the Tortoise. Start one iteration ahead of Tortoise. Okay, what happens if I call next? If it's already none, I think it might blow up. If I should do self dot is sum, and there we go. Okay, never mind, I can't do that. Return none. Let's do that. There we go. Boom. Success. We did it. All right, let me look at the example in the book. A, B, C, D, E, C. A, B, C, D, E, C. Let's change this to be A, B, C, D, E. Okay, change this to a character instead of an integer. All right, run that. The test still pass. However, let's change one thing here, which is I want this to be C. Assert equal cycle results dot unwrap. This should be C. Node character. Cycle result. Oh yeah, this is going to be a a node. No field data, oral. Sweet. All right, so it sort of works. The problem is that I'm getting D. I'm getting in the wrong node. And so how do I make sure that I return the first? And I don't know if there's actually a right answer to this using this algorithm. I think that in order to meet the requirement of returning the first branch, I would need to possibly do this differently. The other problem is once you are in the cycle, there is no, from the point of view of the interior of the cycle, there is no start or end. It's just a loop. It goes around, around, around. There's no beginning, there's no end. Identifying the beginning only makes sense if, yeah, you need to I think you need to use a different algorithm here. So how can we do this? Let me think for a moment here. I don't want to just look it up, and I sort of just want to look it up, but I'm not going to just look it up right now. Let me just check my stream status here. Look at that, we're still going. Still streaming. Let's see. Tortoise and the Hare. So to find out, basically to determine the part of the, like where the cycle begins, how does it phrase it in the book? It says the node at the beginning of the loop. So the node at the beginning of the loop is the node that the end of the cycle points to, yeah? And the only way to know where the end of the cycle is to keep track of, I think, is to keep track of everything you have seen, right? So like one way to do this would be to use a set. And then as soon as you encounter a node you've already seen, that is your entry into the cycle, right? So that's one way to do it. That would require using a set. I don't really want to use a set for this algorithm, but that's one way to do it. That's the easy way. There might be a more clever algorithm here. If there is, I don't know of it off the top of my head. Wonder how other people would solve this. Let's see. Doge, what do you think? What do you think? How should it be solved? Tortoise and the Hare. So one thing that is interesting is that the result here is only one past what I want. So it's almost as if I I think it would be cheating to do this, but if I just get like the previous node, then maybe that would give me what I want. Let's just try it. Let's try it. Let mutable, let's call it previous Hare equal Hare cloned Hare unwrap clone. What do you mean it's not found in the scope? Hare as ref. Unwrap clone. There we go. Okay. Actually, maybe what I want is the previous tortoise, right? That makes more sense. Previous tortoise equals wow, tortoise. Derp. Having a really hard time with my text editor right now. All right, previous tortoise equals this tortoise. So let's just do that. And now it passes. However, I think this only works in the, like I think if you have an even number, then the result is going to be different. Right now it's odd. So if I do the same thing, but I have an even number of these, let's call it datavec 2, E, A, B, C, D, E, F, like that. Let me just format this, cargo format. Okay, and then, yeah, copy this. Let's call this cycle list 2, very creative, 2, list iter 2. Just put a 2 on everything. 2, second node 2. Second node 2. Cycle results 2. Alright, that should be the same. Oops. Should be the same result. No, wait a minute. Yeah, so let me just try to figure out what I just did here. Second case. Let me restart my RLS. Not a super, that's not what comments look like in Rust. Okay, oh yeah, so in the case, oh yeah, that's right. So no, because the second node is still the second node, meaning A, B. Oh, this isn't even right. Oh, you know what? I think the way I had it before was right, because I'm pointing at one moment. What is my code doing? Second node listed are so in the example it's actually not the second node. C, yeah, E points to C, which is the third node. So let me fix that. This shouldn't be, it should be third. Third node should be that guy, right? And this should be third node 2, right? Third node 2. Beauty. Beautiful. Third node, third node. Should be the same result in each case, in either case. Yeah, okay. So this is wrong now. 145. That's what I expected. Anyway, just keeping track of the previous node is not enough. It is a little more tricky than that. I'm trying to think what the options are. So it does circular linked list. It doesn't specify anything about it not being a doubly linked list. I wonder, so I wonder if could do it like this. Yeah, actually, I just had an idea. So I think there might be an easy way to solve this using this previous trick. So keep this, and then I would do this. I'd say keep track of previous tortoise and keep track of previous hare. Like this, okay. And I'm basically going to do the same thing, but I'm going to compare previous tortoise and previous hare. So if these guys are also the same, there's two little friends here, two little friend buddies. If the previous tortoise and the previous hare are the same, then that is what I would want to return, because that would be the first. Yeah, that's fine. That would be the first divergence in the algorithm, right? Okay, and then here all I need to do is keep track of the previous hare, just like that. Ooh, doesn't work. Not quite. Close, but not quite. If these are equal, So if the previous two are the same, they're not. I think my previous Hare should happen before, right? A, B, C, D, E, F. Oh, so 176. Yeah, okay, my test here is wrong. So this one, or is it? No, because it's pointing, the last node is going to be pointing at the third node, but I'm not pointing to the third node. There we go. Nope, one moment. So listed are 2 cycle lists. So this should be, it'll be first node, second node, third node. Third node. This 2 has cycle, this should be true. And this should be C. A, B, C. Maybe I had it right before. Oh, there we go. All right, we're done, I think. I'm not actually totally sure if that's right, but let's go with it. It's good enough. Git add status. Commit, git commit dash a. Problem 8. Let me just check with Clippy. Whoops. Clippy. Before I push that, get rid of this unused variable. 104. Self next as ref. All right, gotta go test. Let me just fix that last commit, push that up to GitHub. Boom. That is it. There's my commit. Build should be starting in a moment. All right, we did it. We did it, team. Woohoo! We finished chapter, whatever that was. Chapter 2. We are on to chapter 3. I just got a winter storm warning on my phone. I'm looking out the window though, and it looks dark. It looks kind of cloudy outside, but I don't see any storm. Chapter 3. Stacks and queues. Stack and sats. That's what all the Twitter thought leaders are saying these days. Jack and friends. Jacking each other off all day long. Okay. Let's check in the dashboard. Oh, look at that. Got one viewer. It's probably me watching my own stream. Let's thumbs up my own video. Why not? Play. Shall we start on chapter 3? I think we should. Let's begin with problem 1. Chapter 3, problem 1. Let's read the problem. Not sure how hard it's going to be. Let's check it out. Let's check it out and see. It's right here. Chapter 3, problem 1. Come on. Come on, camera. There it is. 3 in 1. Describe how you could use a single array to implement 3 stacks. So the question is just describe. Am I not actually supposed to write code for this one? Okay. 3 and 1. Describe how you could use a single array to implement 3 stacks. Single array to implement 3 stacks. Well, sounds very tricky. I'm sure there's a good little trick there. I don't know if I've heard this one before. Maybe I have. I've probably read it at some point, and my brain did not retain this little trick puzzle. This book should just be renamed to like Book of Computer Trick Puzzles. Little trick puzzles. Okay. How could you use a single array to implement 3 stacks? I have to exercise my brain. I want to just look up the solution right now. That's what I would like to do. I'm not going to do that. I'm going to hesitate. Let's just think. Let's use our Sherlock Holmes powers of reasoning here. So what's a stack? A stack is a data structure where you can push things on, boop, 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 and then pop them off. Pop, pop, pop. So it says you can use a single array to implement 3 stacks. I mean, one way you could do it is just do a bunch of like pointer magic. Right? Just have pointers to the start and end of the different stacks within your array. I don't think that's what it's talking about. I don't know if I like the term array also in this context, just because in some languages an array is a thing that you can't necessarily modify, right? Like in C, for example, arrays are, well, unless you allocate it on the heap, I guess, allocate the memory on the heap, then an array is usually like a fixed size data structure, statically allocated. In C++, you would use a vector. A vector is a heap allocated data structure. So what is it getting at here? Describe how you use a single array to implement 3 stacks. I hate this stupid shit. This is so dumb. So dumb. This is stuff you would never ever do. And maybe if you're like in an environment where you have like a 1 megahertz processor, like super low power MCU or something. But what's the point aside from academic? Okay. I'm just reading the chapter here. The chapter is not very dense. It's quite light. It's basically like, what is a stack? A stack is a data structure. You push and pop things on it. A stack is like a queue, except that the order that you Stack is last in, first out, whereas a queue is first in, first out, typically. That's really the only difference. Single array to implement 3 stacks. Well, one way you could do it is with a bunch of pointers. A whole bunch of pointers. Think that's one way? You can do that. It would be kind of crappy. I wonder if my sound's working. I should do a sound check here. There we go. Sound's working. Just sound check. We're good. We're good on the sound. I wonder if I should actually try implementing this. There's got to be like a nice trick, something that I'm not thinking of, right? I'm sure it's really obvious. Like once I realize the trick, it'll be like, oh, but of course. And the thing with these is that it's all in like how you frame the question as well. Like these tricky questions become a lot less tricky when you just ask them in a more obvious way. But in the context of interview problems, you're asking them in a way that it's like, here's a little riddle, which I need you to unriddle for me. I mean, I don't know. I mean, like maybe one thing they're thinking about is like using the bit field of integers in a stack or something, or in an array. That would be pretty insane, but you can do something like that. Single array. Okay, I give up. I quit. Let's look at the answer. Let's go to the GitHub thing. Java, chapter 3, 3-in-1. Fixed multi-stack. Well, let's look at fixed. Number of stacks, 3. Stack size times push is full. Sizes. Oh, it is just doing a bunch of pointers. Of course. This is so stupid. Why? This is just so stupid. Why would you ever do this? I hate this so much. Okay, sure, you could do this. The only reason why this makes sense is because it's doing this with a fixed capacity. But like, this is just such a stupid problem, honestly. Sizes. Or does it grow the stack? Push. I see that it's actually keeping track of these sizes. I don't know if that's just static or if the more puppy dreams. Yeah, there's no more puppy dreams left, I'm afraid. Puppy is sleeping. Oh, I meant to be sharing my screen. Let me fix that. Whoops. Let me share my screen. Let me check on Puppy. Yeah, Puppy's asleep. It's puppy nap time. Where's push? So if is full. Yeah, okay. It is doing what I thought. So I guess I was right. It's just doing a bunch of pointers and shit, which is really dumb, but whatever. Let's, why don't we do it? Why don't we just implement it? Chapter 3, problem 1. Okay. 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 Just gonna copy main here over, so I don't remember how to run main, how to write main. Get diff, get status, get add. Let's add our new file, problem 1. All right. 3 in 1. Let's do it. Struct 3 in 1. It's going to have a vector. Doesn't matter what the type is. 3 stacks. I guess it should be generic. 3 in 1, type T. It's going to have a just call it R array, vector of type T. Okay. And let's have another structure. I'm just going to call it pointers because that's a good language. Let's say 1, I32. Maybe this should be usize. Let's do that. 2, usize. 3, usize. Pointers, pointers. Okay. Now let's implement new for this. New. What does new look like? Self. I think I need a T here. T, new, self, return self, yeah. Let's call it capacity, usize. Okay. And then I'm just going to return a 3 in 1 guy. How do I do that? Like that? I don't know how to do this in Rust. Array. Back. Let me pause for a moment. All right, I'm back. Unmute myself. Also just occurred to me that while this, I just closed it. Let's go back to the Java solution here. I realize it says fixed. This probably does not mean fixed as in working. This probably means fixed as in fixed size. So let's look at how, oh yeah. So this is what I thought. This is a bunch of, basically a bunch of like pointer manipulation. So that's fine. I'm gonna basically do the same thing in Rust. Let's do it. Although, yeah, my pointers, so this should actually be like start and end, right? One start, one end. Let's make this a little less silly. Start and derp, 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 derp. Okay. Array, and then one pointer. So I'll have 1, 2, 3. 2, 3. Yeah, just like that. Beauty, beauty. I'm making some tea. Fresh tea. Fresh, hot tea. I should be buying Earl Grey. That's what Picard drinks. As a bald person, I should only drink Earl Grey tea. I think there's like an international law about that. All right, so if I have a brand new vector here, it can be empty, size type T, new, yeah, whatever, empty, and then one pointer, 0, 0, 1, 2, 3, 3. 1, 2, start end. Why does it not just let me do that? Why can't the compiler just know what it is I'm trying to do and just make it happen? Cool. Okay, that compiles. Restart my RLS. Okay. So how would this work? Very simple. I want to look at the Java interface and just see what it's like. Multi-stack, number of stacks. Okay, so this is a little more generic. Allows you to specify the number of stacks. There's some size, blah, 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 blah. So what happens when you push? So I see. So it's basically like, have to like shift everything around. What a horrible data structure. What a nightmare. I think I can actually probably do this a little easier. This will probably be a little easier to do in Rust, believe it or not, because I can just splice things. So it won't be that bad. And I'll just make copies of the array whenever I want to change it, and just copy it, because who cares, right? So push Yeah, cool. So I'm gonna do this even differently actually. I'm not even gonna have like a capacity option. I'm just gonna have it splice in and splice out every time. Okay, let me just copy the test boilerplate here from this one. Test 3 in 1. Okay, beautiful. So let 3 in 1 equal 3 in 1 new. Let's make it of 3 in 1 of type integer, 32-bit integer. Does that run and compile? Yeah, that does it. That's step 1. Okay, so let's add a push. And since it literally says 3, why don't I actually just make it arbitrary though? So I'll just say pointers. This would just be a vec of type. Sorry, a vec. Yeah, whatever. And I'll change this to just be pointers of type pointer, like that. Initialize with an empty vector. Yeah? What's the interface in the Java? So to push, specify the stack number and the value. Okay, easy. So 3 in 1, and then basically just say 3 in 1 dot push, stack number 0, value 1. 3 in 1 dot push, stack number 1, number 1. No, let's do number 2. 3 in 1 dot push, number 2, 3. Okay, and then let's pop them all off. Pop number 2. Let's assert that's equal to 3. Okay, and then let's pop off number 1. That should be 2. And then pop off 0. That should be 1. Okay, and then repeat this once more, but with some more stuff. Let's do 4, 5, 6, and let's do 7, 8, 9, and then if pop again, it should be 9, 8, 7. That's it. All right, let's implement push and pop. So function push. So we're going to have stack usize rest vector. I think usize is the right type. I want to know what type I should use to index on the vec, and range. I think usize is the right parameter. Well, whatever, let's try it. Stack and then value type T. Okay, so push is going to first check if my pointers exist for this guy. So I'm gonna look at the size. How do I get the size? Length. Okay. So if stack.length is less than the stack I'm trying to select, -1. So like if I want to select, no, not -1. Let's do stack length -1. Yeah, okay. So if the length is less than that, then I need to go stack.resize. Sorry, not stack. This should be, this needs a self parameter. This should be self.pointers.length. All right. And this should be mutable self. Yes. And okay, so self pointers new size should be stack +1. Okay, and the new value should just be a pointer with start 0, end 0. That's it for that, for the case. Okay, let's add a pop here really quickly just to make the compiler able to compile. Let's go pop stack, and this will return T. Just make that a 0 for now. Can I do that? I don't know if the compiler's gonna like that. I think I need to use resize with pointers, resize with stack +1. Let's make this return an option of T so that I can put none here. Fix these guys, fix that, fix that, fix that, fix that. Cannot borrow is mutable. There we go. Rocking and rolling. Okay, so let's implement push. So if we're pushing onto the stack, it's very simple. So let's look at splice. How does splice work? Splice range, splice width. Examples. Creates a splicing iterator that replaces the specified range in the vector with the given. I don't want that actually. I think I want insert. There we go. Insert index element. Inserts an element at position index within the vector, shifting all elements after it to the right. Bingo. Self array. This is almost too easy. So I merely insert at self.pointers stack, insert at the start this value, and then I need to basically shift all pointers after this. Yeah. So, okay, so for pointer in self.pointers, .iter.skip stack basically skip n of them. And then I'm going to just shift all these other pointers down. Whoops. This should be pointer.start plus equals 1, pointer.end plus equals 1. Something like that, right? Because I inserted, so I'm just shifting everything a little further down. I also need to shift the end here by 1. This should be immutable iterator. All right, pop. Gonna be the reverse of that. Okay. Drain. So drain creates a draining iterator that removes a specific range. Wonder if there's like a pop. I just want, oh, there is a pop. But that's not, I want to pop from a specific index. Remove item. Ooh. No. Removes the first instance of item. Not quite. Resize width, split off, clear length, drain. Remove. Oh, there we go. Remove, removes and return. There we go. That's what I want. So pop, I'm just going to say let result equal self.array .pop, where self pointers, whatever stack I want, popping from the start basically. Okay. I need to decrement the end here, minus equals 1. And then do the exact same thing here. Shift everything. Shift my pointers, basically. All of them down by 1. Some results. And then I'll say if I don't really care that much about doing error checking here, but I'll do it anyway. If stack or if self dot pointers dot length minus 1 is less than stack. Turn none. If, let's do that, or, so that's one case. Another case is that this is empty. So start is equal to end, then that is empty. All right. Oh, that should not be pop. That should be remove. Cargo test. It's failing. It's compiling, but it's failing. All right, let's try and figure out why it's failing. Line 20, panicked, attempt to subtract with overflow. What? Line 20, oh, I see. I can't do the math this way. I need to do if pointers.length is less than stack plus 1, yeah. I think I have the same math problem down here. Line 41. This shouldn't be happening. If my code is right, then these guys should all be correct. Clearly my code is wrong. They should not be overflowing here. Let me just implement debug for these guys, or drive debug for these guys. Okay, print some debug stuff. There we go. Okay, so I added one array, one pointer, start, end. Yeah, that's right. Okay. What happens after I add 2 and 3? Let's go there. Yeah, array 2, 1, 2, 3. Oh, I see. I'm messing it up. So pointers 0, 1. Yeah, okay. Definitely doing this wrong. I think that I shouldn't be skipping that many. No, that's wrong too. So it should be, there should be 0, 1, 1, and then 2, 3, 3, 4. But I am let me just look at what skip does here. What does skip do? Skip creates an iterator that skips the first n elements. So if I say skip 2, then it should give me 3. Yeah, so it should be +1, right? And just add some more prints here. Before, after, yeah, like that. Okay, before, after, that's fine. Before, after. So this was wrong. Oh, no, this is right. But I see, okay. I understand why it's messed up. It's because when I initialize a new, I'm initializing all these guys to start here. But I need to get the last end. All right, let last end equal 0. All right, if self dot pointers dot length is greater than 0, then the last end should be mutable. The last end will be self dot pointers dot last dot unwrap end. All right, looking better. Tempted to subtract with overflow. 50. This should be +1. Change that. Boom! It works. We're done. We're done. We're done. All right, let's run Clippy. See where I messed up. Thanks, Clippy, for letting me know all the different ways that I am not a good person. I just add this into main. Whoops, 3 and 1 pop 0, just to make cut down on some of the unused warnings, if else expression. Why am I not getting my Clippy warnings actually right in VS Code? I think I may not have that enabled. Rust, Clippy, 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 Clippy. On. There we go. That's why. That's why I'm not seeing my Clippies. There they are. If let Okay. This doesn't need to be mutable. How are we doing, Clippy? We're good? Length comparison to 0. If empty is so like a not empty. Is there a not empty? Not non-empty, empty. Pop, clear. Returns true if there are no elements. Alright, whatever, good enough. What other Clippies do I have? Is that my only Clippy? Sweet. Alright, let's commit that. Chapter 3, problem 1. Status. Problem. Chapter 3, problem 1. Boom! I think I officially have the most complete version of this in Rust now. What a miracle. Well, probably gonna, let's see. Let me look at what the next problem is. Check my stream status here. The next problem, stack min. How would you design a stack which, in addition to push and pop, has a function min, which returns the minimum element? Push, pop, and min should all operate in order one time. Okay. Push, pop, and min. How would we do that? So, keeping track of the smallest element is relatively easy when you are adding new elements, because all you have to do is keep track of the min. When you encounter a new smaller element, then you update that min. In the case where you pop, however, it becomes more difficult. Unless you basically have two stacks where you keep track of, like you could effectively have a multi-stack. I think that's what it's getting at, where you push the, well, no, I mean, there's got to be some sort of ordering. Like, you need to know which one is the minimum and then which one is the next minimum. in the case of pop, right? Because you pop something off out of the stack, you need to know which is the next smallest one. And to make that order 1 is only possible if you already have a sorted list of the values. So you could effectively have like two stacks, one or two arrays, one which is ordered by the order in which something was pushed onto the stack, and then another which is ordered by size or ordered by value. Actually, no, that's not order 1 either, because it's order n to do an ordered insert. How's the function min? So the problem with min is that it says that it needs to be ordered 1. So how do you Oh, look at that. There's snow falling. Snow falling from the sky. I think that's snow. Looks like the storm is happening. We're in the storm. All right. Min in order constant time. Let me copy this, paste, chapter 3, problem 2. Here we are. How would you keep track of the min in constant time? I'm sure the answer is something really straightforward. Let's think about this for a minute. Three, two, one, 1, 2, 3. So I suspect that there's some relation between the last problem, problem 1, and problem 2 here. And I think the answer must have something to do with these two questions. They must be related. They must. Everything is happening for some kind of reason. Okay, I'm pretty sure that the way probably this is expected to be done is using some kind of multi-stack. And when when you push an item onto the stack, can't really push an item onto a stack in a particular order. Stacks are not, well, they're ordered, but only ordered by when you push the item into the stack, right? That's the type of ordering. How should I do this? How would you design a stack which, in addition to push and pop, has a function min, which returns the minimum element? Push, pop, and min should all operate in constant time, order 1. Well, let's just try this. Stack with min. Okay, push 1, 2, 3. Pop 3, 2, 1. Stack with min. Just call this stack. Okay, let me just update all this, and I'm going to change this to just stack. And it's just going to be a vector for now. This is kind of a goofy implementation here, but whatever. I'm also like literally just implementing an array, or re-implemented the array here. Push value sum self dot array pop. Oh, this actually already returns an option. Sweet. Push back of a collection removes last element. Okay. So that's too easy. Restart RLS. It's way too easy. But of course there's a trick here. All right, min element of type T. So if value is less than array.min, then self.array.min equals value. Min self option T should be an option. Stack min none. Initialize that to none. So this should be if self.min dot is none. So if it is none, it should just be initialized like that. This can just be an or actually. Something like that. Does that compile? Gotta restart RLS again. Binary option where T std num compare must compare trait compare must std compare partial equal, right? Partial order. Cannot move out of board content. I don't want to move. I want to make a copy. I just say cloned. Clone exists. Copied. Why is that trait not satisfied? Rust return option copy. Copy. Copied. Maps a option to by copying the. Yeah, I just want to copy. Why can't you just make a copy of yourself? Just make a copy. Make a copy of option. Okay, I'm doing something really stupid here. Maybe I just need to unwrap this. No, because that doesn't even make sense, right? Like, okay, let me just fix one thing at a time here. Can I move? I want to copy this guy. Can I just say clone? No method clone. Alright, can I just specify that this has to implement clone? Why can I not do a comparison on these? It seems so simple. Okay, let's min val equal. No, so I don't know if it's actually expected type T. Why can I not just unwrap it? Unwrap. Right? I don't want to move it. I just want to unwrap it. Like, why is that so hard? Cannot move out of borrowed content. I'm not trying to borrow it. Ah, as ref. Can I just do that? Can I just unwrap it? Do I have to like deref it? Ah, there we go. Okay. Goddamn Rust. Sometimes it's like really WTF. What the fucking fuck? Let me make this an option, ref option. There we go. Option ref. All right, there we go. Assert equal stack with min dot min. Unwrap. Min should be 1. This is a ref. Goddamn. I don't want a ref here. There we go. So that sort of works, but problem occurs when you pop, right? As soon as you pop, the min changes. So this is all constant time right now. And it is pretty straightforward. Now it'd be easy to convert pop such that it updates the min with the next smallest, but that's not constant time, which is what it says. It says they should all operate in constant time in the book. But I'm not sure how to do that without introducing a bunch of other, or at least one other data structure, or dealing with, yeah, something else. And there is really no constant time way to keep track of the order of things. Returns the minimum element. The minimum element could be anywhere in the stack. So I'm going to do a thing, and I don't care, is what I think. Okay. So self array is empty. So if it is empty, then self.min becomes none. There's no longer a min. Otherwise, self.min becomes some self.array first for value in all right. Three, two, one. This is not working. I'm not sure why that's failing. It's blowing up at line 58. 58, right here. Push, push, push. Oh, yeah, change the order of this. Should be 3, 2, 1. 3, 2, 1. $158. Oh, it's gonna be 1, 2, 3. There we go. Okay. All right, that all passes. That's not constant time, but I don't care. Right now, I'm gonna ignore that, and I might think about this problem and come back to it later. That's where I'm at. where I'm at with this. Let's add the new problem, add that, add I don't know why, I don't know what changed on the other one. Why are there no changes when I do a diff? All right, whatever. Let's add chapter 3, problem 2. Push that up to the hub. Should be there. Chapter 3, problem 2. Yeah, so this, again, this algorithm is not constant time. Finding, when you pop, finding the next min is order n, which honestly isn't that bad, but the next best option that I could think of would be essentially the flip of this, where on push you would keep like an ordered list around, and you would insert new entries into the right position in the list, and then finding them in is really simple because it's just always at the top or whatever, or the head. I'm not really sure what the book has in mind, but I'm gonna think about it, and maybe I'll come up with something better while I'm sleeping. But I think this is pretty good enough. Anyway, thanks for tuning in for this edition of Crack Into the Code and Interview. Cracking the code. We're cracking the code, but we're not doing crack. Not on here. Not today. Probably not ever. Not me, at least. But, you know, you do your thing. You do you. Whatever that is. Thank you for watching. If you enjoyed this, hope you get some value out of it. Maybe you're watching the recorded YouTube versions. These videos are really long. I hope if you are watching them, you're watching them at like 1.5 speed. Keep it, speed it along a little faster. Shorten the amount of time you have to look at my face. It's good for your health, probably. Okay. Anyway, yeah, thanks for watching. Check out the GitHub repo if you'd like to follow along. Let me just show that again. It's under my name, Brenden Matthews, no vowels, / cracking the coding interview with cracking the coding interview Rust. Check it out. Oh no, my build is failing. I guess I need to fix the build here. Rust format, cargo format, fix formatting. Okay, let me fix the formatting. Don't know how that broke. Let me make sure that builds. Anyway, yeah, thanks for watching. Hope you get some value out of this. Hope you learned something. And if you're trying to pass some interviews, if you're new to the computers, maybe check out the book or check out the problems at least. It's good practice, even just to go through and try to implement the problems. This is something I'm doing partly because I want to learn Rust. If your stack contains say 5, is there at any point in tracking any number greater than 5 for the minimum as long as 5 is present in the stack? Let me think about that. If your stack contains 5, is there any point in tracking any number greater than 5 for the minimum? No, like if your stack contains whatever, you only need to keep track of the minimum, right? And that is strictly what I am doing in my implementation. Maybe you are saying something that is going over my head. I maybe don't understand what you're saying, but in my case, all I am keeping track of is the minimum value, right? Or rather here. All I keep track of is the smallest value. So every time you push into the stack, it basically checks that value against the minimum that it's keeping track of. If the new value is less than this minimum, then that becomes the new minimum, right? That's super straightforward. The problem is on the pop side, or I mean, again, like you could do it the other way around, it doesn't matter. The problem is that you still need to do an order n search every time on one of these operations to find the next smallest, right? Like if you pop the value off that is the current min, then you need to do this again, right? Also, I just realized this, I made a mistake in my implementation here. I only need to go through this if, I only need to go through this check. Nope, combine this with your multi-stack idea, just a hint. Yeah. What you're suggesting is not clicking to me right now. There's gotta be a better way to do this, I'm sure. But hold on, let me fix this one particular thing. I'm definitely not comprehending what you're saying. Hold on. Let me fix this. This does not... This code doesn't need to... actually, no, that's fine. Cargo format. I'm going to leave this as is. Why is VS Code freaking out? Switched from 4 spaces to 2 spaces. I think that's why it's fighting with Rust format and why the build failed. And I get it now. Okay, anyway, that is passing. Anyway, okay, yeah, I'm still thinking about, I don't know what you're getting. I'm sure that like the actual solution is really simple, and once I realize what it is, I'm sure it involves multi-stacks, since the previous problem is this 3-in-1 stack. That's a pretty big hint for how to solve this. Although I guess my brain is just not good enough. I'm not good enough at computers to actually figure it out right now. So that's that. It is what it is. I am who I am. I'm going to sign off, however. Thank you for watching. If you've been watching, hope you enjoyed. I'll be back next weekend, perhaps. Unless I find something else I want to do, then I'll probably be back. Please drop by, tune in again. Take care. Bye-bye.